process the information. A lot of things are processed automatically without you thinking about it. It's subconscious. And if it's somatic, it'll go, which is skeletal muscle control. It goes to the somatic nervous system, somatic effectors. And it'll affect skeletal muscle. If it's visceral, which is your internal organs, it goes to the autonomic nervous system, parasympathetic or sympathetic, and it controls the visceral effectors, smooth muscle, glands, cardiac, muscle, and adipocytes. If it's, usually it's interlinked with some stuff is actually routed to the higher brain for processing at the conscious level, which can be affected by memory, learning, planning. A lot of stuff happens without you ever thinking about it. Some of it you're made aware of, so you can modulate it as needed, especially when you want to control body movement and things like that. So, a couple of terms that are in your notes. So it's all in section 4.6, but I'm going to go through a little bit more of it. So even if you have no stimuli going on, your autonomic motor neurons maintain a low level of constant activity, which we call autonomic tone. Just like about how muscle is slightly contracted, which indicates muscle tone, we have autonomic tone. Some organs receive information from only one of the nervous systems, the sympathetic or parasympathetic. Many get what they call dual innervation. And the effects can be complementary or opposing. And in some cases, the receptor can vary, but you don't have to worry about that. I'm not going to ask it. And so the book goes through all these, if you look at chapter pages 44, 45, the book gives examples of several organ systems and how they're affected by either sympathetic or parasympathetic. Most of these you don't have to know. There's not any in the notes, but there's like a few that I want you to know, so I'm going to tell you which ones. The first one is the eye.
You told us this, right?
So check off eye, you need to know it. Sympathetic dilates the pupil, and also allows to change your lens for long distance vision, looking far away. And parasympathetic constricts pupil, and it changes your lens for close-in vision. You'll learn about all this in chapter 15, which reminds me, as I said before, if you want to get if you're taking AP2 in the springs, you want to get a start, 15 and 16 will be the first two chapters. For me or Dr. McConnell, whoever you take. So that's I. That's the only one you can know on this page. The rest you can skip. And notice, sweat does increase by parasympathetic stimulation. No, I won't ask that one. I is one. Second one, notice, I won't ask you any blood vessels, no blood vessels, but notice, all of them are sympathetic only. There's not any parasympathetic. They can either dilate or constrict depending on the type of receptor in given blood vessels. Just showing you how it can react, so which receptor you have dictates how it responds to different organs. But again, I will not ask you blood vessels, so you just cross it off. Check off heart. I will ask heart. Heart, sympathetic, you increase heart rate, force of contraction, and blood pressure. Parasympathetic does the opposite. It slows it down, decrease heart rate, force of contraction, and blood pressure. Sympathetic up, parasympathetic down.
You've already done this.
Have I?
Yes.
Okay. Oh well, I forgot.
What's the last two?
Someone said start section.
Pancreas and reproductive.
To the heart, pancreas, male reproductive system,
Pancreas,
female.
insulin, and what was the next one? Reproductive?
Of the male and the female.
And that was it.
And that's it.
I think that's it, yeah.
The male and the female reproductive system. It's on the other page. At the bottom. Male, female. That's it. Just those.
Okay, so then we'll go to, well, one thing I will mention, this is from your book, they give an example of how your heart rate can be affected by sympathetic or parasympathetic. So again, one thing I want you all to remember is that under default conditions at rest, parasympathetic is in control.
of the
You
study.
only excite, the sympathetic only is activated because of exercise or emergency or, fight or flight conditions where something's happening, then you get excited. Then usually once the excitement ends, this parasympathetic takes over and slows you back down again. So both are active, but parasympathetic is in control. If you increase parasympathetic, you lower the heart rate. If you have an emergency, sympathetic stimulation will increase it. And you can either parasympathetic inhibition or sympathetic stimulation. Then if you have increased sympathetic, that'll, and no parasympathetic, you'll even have a higher rate of heart contraction. Okay, so the next section is on visceral reflexes. And as it says in the title of 14.7, most visceral functions are controlled by visceral reflexes. And again, it's just like the the somatic reflexes we had in the other chapter. They have a reflex arc with the same components. They're all polysynaptic, so you have more than one interneuron. It's the usual things that you've already seen. You have a receptor that monitors the signal, and they can be thermoreceptors, baroreceptors, chemonociceptors, all these things. A sensory neuron carries it to the CNS processing center, either in the spinal cord or in the brain stem. Then you have visceral motor neurons, usually two, that control the signal. They show examples of this on page 486. So there's two types of reflexes. One is short, which you totally bypass the CNS, and you relay with signals in the ganglia, interneurons in the ganglia. These control simple motor responses with localized effect, just part of an organ. The enteric is a big example of this. It's all done within the digestive system. And here's an example of a short reflex. You have a stimulus by the receptors in the tissue. It goes in on an afferent sensory fiber, synapses in an autonomic ganglion, and they send out a signal by the ganglionic neuron, and it affects the receptor, the effector. That's short. Outside the central nervous system, goes through autonomic ganglion. The long, which is the alternative, it goes, the sensory neurons will enter the CNS through dorsal roots like you've already learned in the earlier chapter. It's processed in the CNS, again, brainstem or spinal cord. Then they'll send an effect out. AS motor neurons carry the response to the visceral effectors. The long, since it goes into the nervous system, they're dominant over short reflexes. They can activate the entire organ or even coordinate many organ systems in a large response. And here's a picture of that from your book on page 486. So again, you have a stimulus. Afferent neuron goes to the spinal cord. Interneuron for the response, and then you, since it's a autonomic, it's got two neurons, one from the spinal cord to the ganglion, and the second one from the ganglion to the effector. Looks like you learned about in an earlier section of the chapter. And so a long reflex is an autonomic equivalent of a polysynaptic. It's just like the one you've already seen in early chapter 12. Or whatever chapter it was, but it's just autonomic instead of somatic. Then on page 487, they give examples of this. You don't have to know any of these, except the only one that we sort of talked about in the other section was the male and female sex response. But I want to go over these just so you can get a feel for it, but I won't ask any of them on a test. So, for example, you've got